C be the set containing apple, banana, carrot, date, and egg? Part A. How many subsets are there? Before we proceed, let's make note that the cardinality of this set, that's the number of elements in it, is 5. Now we can use the power set rule. The power set tells us the number of subsets is, what we want is the cardinality of the power set of C. The power set is the number of subsets possible, and for each element you have two choices. It's either in the subset or it is not in the subset. And so for each of them there's two choices, and there are 5 elements, so it'll be 2 to the 5th. That's supposed to look like a 5. And so the number of subsets is 32, which is 2 to the 5th. Part B. How many subsets contain neither a carrot nor an egg? What we need to do now is reduce the set size, and so we'll go from the cardinality of the set, and then we'll subtract the cardinality of the set that contains a carrot and the egg. And so this becomes the arithmetic problem of 5 minus 2, or 3. The set that does not contain a carrot or an egg has 3 elements in it, and then we'll use the power set rule, which tells us we take each element that's still remaining, that would be an apple, a banana, and a date, and it's either in the set or it's not, so it's 2 cubed, and that number is 8. Question part C. How many subsets of cardinality 2 are possible? The question that's asking is, in how many ways can 2 be chosen from a set of 5? We are solving for in how many ways can you choose 2 from a set of 5. This is a combination. The formula we use will be 5 factorial divided by 5 minus 2 factorial times 2 factorial. Part C. How many subsets of cardinality 2 are possible? The problem here is asking, in how many ways can 2 be chosen from a set of 5? So the problem is actually 5, choose 2. Then we'll use the formula for the combination and compute that as 5 factorial divided by 5 minus 2 factorial times 2 factorial, which is 5 factorial divided by 3 factorial times 2 factorial. 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1 times 2 times 1. Let's cancel. I'll do the 3 2 1s and 2. That'll make the reduce the 4 to 2, so 5 times 2, or 10 different subsets of cardinality 2 are possible. And finally, part D, list all the subsets of cardinality 2. I'll use the letters A, B, A for apple, B for banana, C for carrot, D for date, and E for egg, and systematically select 2 starting at A. So we could have a subset that consists of A and B, moving over A and C, moving over A and D, and finally A and E. Now let's move to the right and we'll begin with B. There's no reason to pick B and A because we already have A and B, so we'll go to BC, BD, BE. Let's go to C. We don't need CA because we have AC. We don't need CB because we have BC, so we can have CD and CE. Now let's move over to D. Moving to the right, we can have DE. Now let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Consistent? We got the 10 subsets of cardinality 2. How many